AP Physics B, section 1.7. We're going to look at the components of a vector. And this is going to be a useful way to help us add vectors in the future. We're going to be doing a lot of working with components of vectors, but we're just going to look today at exactly what a component of a vector is. Components will add together to equal the original vector. Typically we break vectors into their x and y components, although you can break vectors up into any multiple number of vectors. But in our class, we typically will break them up into their two vectors, their two component vectors, their x and y components. And like I said before, you can break vectors up into any number of their components. An example of components would be, here when we're sending this projectile. We shoot this stone up in the air, follows this parabola, and you'll see that this vector right here is the actual velocity vector. And the two components are here. This is the x component right here, and this is the y component right there. And this original vector has been broken up into its x, y components. And we'll see later on when we study physics further why we do want to do that. But that's a typical example of breaking up a vector into its x, y components. When we draw vector components, we can take our vector components and draw them like this. If we have this resultant vector, let's say, or we have this vector similar to the one we just saw, there's some vector here. We can break it up into its x, y components. And the way you would do that is draw a triangle, a right triangle. There's the x component. Here's the y component. And they form a right triangle. And that's one way of drawing them. The other way of drawing them is like what the previous drawing did. We can take our vector that we have here, so it's like this, and we break it up into its x, y components, but instead of forming a triangle, we draw our x component like this, and our y component like that. It really is the same idea, it's just, a different way of looking at it. This one is like this, here, and here. So those are the two ways we'll be breaking up our components our vectors into their x, y components. We're going to take a look at two examples to hopefully make this a little bit clearer. Our example one is this. Again, it's a projectile, and I'm going to take the velocity. We're going to look at the velocity vectors. And we're going to start this off, and you can see those vectors changing the x, y components. We'll reset this. And let's start this again, and let's do this in slow motion. So we can actually watch those x, y vectors changing, those x, y components changing. You can see the actual vector itself is just following along the path, and those x, y components. Actually, the x component you'll see never changes. It's the y component that actually changes. Let's reset that. And the x component you'll see, in this case, never changes. It's the y component that always changes in this particular problem. And that's why we break up into its x, y components, because the x velocity vector doesn't ever change. Okay, so let's go to our second example. And what I'm going to do is I'm going to take this vector here and move it around, and what you'll see is the red arrow is the x component, and the blue arrow is the y component. You can see as I move it along, the x, y components will change as the vector changes. Kind of gives you an idea of how it's drawn. And we can also do this component style. This is the other component style that we did. In certain cases, it's easier to draw it one way than another. We'll just get used to that idea. But here's a different way of doing it. There's another style here. You do it up on top like that. It doesn't have to be along the x-axis. You can do it up on top. It makes it a little bit easier to work with sometimes. And this last style is more like a parallelogram, but it's really a rectangle. But those are our x, y components. You see that they always, form that Pythagorean theorem. That's what's kind of nice about it. It's easy to calculate the x, y components. We're going to go ahead and calculate the vector components here. And actually, let's just say I didn't know this one here. So if we said, all right, our resultant is 10 newtons, and one of our components is 6 newtons, I'd want to find the x component. know the y component is 6 newtons. I want to find the x component. Then we would simply do a squared plus b squared equals c squared. There's the Pythagorean theorem. And we would find out that using that, the opposite side here, if we did 6 newtons squared plus b squared equals 10 newtons squared, we end up with the answer b equaling 8 newtons. And typically we want to find the angle that it's at also. This would be our angle right here. It's theta. And we can do whatever trig identity, trig function that we want to use here. So, for example, I might say theta equals inverse sine of opposite over hypotenuse of 6 newtons over 10 newtons. And that theta, that angle, ends up equaling 37 degrees. So our resultant here would be 10 newtons at an angle of 37 degrees. We broke it up into its xy components of 6 newtons and 8 newtons. So to wrap section 1.7 up, we know that we learned what a vector component is. We learned how to draw the components. And we learned how to calculate those components.